The Pythagorean theorem. This is 8.1, 8.1 notes. Okay, and we're going to look at the PT, Pythagorean theorem, and its converse. Okay? Alright, Pythagorean theorem. You should already know that one off the top of your head. But if I were to say it, if a triangle is a right triangle, then what happens? If you have a right triangle, what happens? Fill in the blanks. See if you can fill in the blanks. If we have a right triangle, so given right triangle, then we can say, there we go, I like that. Then we can say the sum of the of the lengths of the legs is equal to, let me finish this, the of the length of the hypotenuse. You're trying to fill in the blanks without looking at your book. So given right triangle, then we know that the sum of the lengths of the legs is equal to the of the length of the hypotenuse. Okay, I'm going to say it. Here it goes. Did you guess it? Did you say it out loud? State it. The sum of the squares of the length of the legs is equal to the square of the length of the hypotenuse. You're like, what? Yeah, because this is the Pythagorean theorem, not this. No. The magic exists in the Pythagorean theorem in the squares. Okay, I want you to go ahead. Oh, there's one other thing I have to cover. With that, if I extend this idea, the Pythagorean theorem, there's something known as a Pythagorean triple. This is a vocabulary term, Pythagorean triple. Okay, these are a set of non-zero whole numbers that would satisfy a squared plus b squared equals c squared. The key there is that they're a set of non-zero, can't be zero, whole numbers that satisfy this Pythagorean theorem. And those are known as Pythagorean triples. So, for example, the most famous one on earth is the 3, 4, 5 Pythagorean triple. Because 3 squared plus 4 squared is 5 squared. And those are all non-zero whole numbers. Then another one to know is 5, 12, and 13. That'll work. 5 squared plus 12 squared is 13 squared. Okay, there are others. You can keep going, but you could also double this and get another one that works. 6, 8, and 10. You could double this one to get another one that works, and so forth. So that's just something to keep in mind. Set of non-zero whole numbers. Pythagorean triple. Alright, I want you to go ahead and try the got it problem. Got it problem number 1, A and B. And go ahead after that and try got it number 2. And this is all on page 492. Okay? You know what? I'm going to have you go ahead and do got it number 3 also. So prepare yourself for all those and then start the video. So in problem 1, I'm going to start it. So hopefully you are finished there. And you know what? I'm going to pause the video and I'm going to do it, and then I'm just going to record my answer. Okay? and then I'll see if you need it to be explained. So I'm going to pause, and I'm going to go ahead and do it also. All right, so in Got It problem 1A, that I already have the work done for, because I feel like you do not need me to go through it really here. In 1A, I got an answer of 26. 26, whole number. So it worked out nice. In 1B, is that a Pythagorean triple? 10, 24, and 26? Yeah. And you wouldn't just say because it passes through a squared plus b squared plus equals c squared, but because 10, 24, and 26 are also non-zero whole numbers. All right, let's go to Got It number 2. Got It number 2. Here's my info. This is what I did with it. I solved. And in this case, if you read the directions, we'll see if Ben read the directions here. I'm sure Leah did. She probably got this one right. Henry also. Murphy, are you talking? Are you focusing? Please. And Ella's probably thinking about climbing. So, square root of 108. I need to simplify that. And I did not show the work on this because I want to show you how to do it, because you might have forgotten. So 108, I need to figure out a perfect square that goes into 108. So my first perfect square, 1 squared, is 1. Well, I'm not going to use that. 2 squared, 4 is perfect square. Does 4 go into 108? Yeah, it does. But maybe the quicker, more efficient method is going to be to find the biggest perfect square that goes into 108. So I'm going to see if there's anything bigger than 4 that goes into 108. Or, you know what? Let's just go with it. Let's just go with 4 and be done. So let's try this and see how this works. So I'm going to split the square root of 108 up into 4 times, and 108 divided by 4. Again, yes, Ella, you can make use of a calculator here. It's 27. And now, right when I see this, right when I write this as a mathematician here, I see 27. I'm thinking in my head, oh man, I know another perfect square in 27. 9 goes into 27. That's perfect square. So that's why this problem sort of extends itself. So I'm going to go that the square root of 4 is 2. And then I have the square root of 27, which now I'm going to split up because there's a perfect square in 27. So now I'm going to have 2 on the outside, and I'm going to split up 27 into 9 times 3. And so now I will end up with 2 times the square root of 9, which is 3, times the square root of 3, which I leave in the root. So the square root of 108, simplified version, simplified root version, is 6 root 3. And I do want to show you that based on my work, I can figure out what the biggest perfect square that goes into 108 by looking at the 2 perfect squares that I found, 4 and 9. If I multiply those, that's 36. So I could have split up 108 like this. Let me show you. I'm excited to show you this. Here we go. 108, 36 times what? So if I take 108 divided by 36, that's 3. And then the square root of 36 times the square root of 3 would end up simplifying to 6 root 3. Okay, but either way I get there. All right, then you had the Got It problem number 3, solving. And in this case, if you read the directions, then it says to this time not simplify it into root form, but to simplify it to the nearest tenth. So I'm going to look here. This is what I got when I computed on the calculator. And now is that 4 going to stay or move up? And it is going to move up. So I have 15.5. And there was probably a unit on that. Okay? All right. So now moving onward from there, because the section is still not done, I have to find my book. So hold on. Alrighty. So now extending your notes, because we covered the Pythagorean theorem. Now what about the converse of the PT, Pythagorean theorem? Well, the converse is just going to be switched. So I'd say if the sum of the squares of the lengths of 2 sides of a triangle is equal to the square of the length of the third side. If the sum of the squares of the lengths of the two sides of a triangle is equal to the square of the length of the third side, then what can we say? We have a right triangle. Okay, so if this happens in that triangle, we know it's a right triangle. We know it's right. Right? Okay, right. All right, so go ahead and try. Got it, problem number 4 on page 494. And I'm going to work it through, pause the video, and show you my work because I think it's pretty simple. Okay, so in the got it problem number 4, in part A, is the triangle a right triangle? Well, look at what happens here. The square of the legs does not equal the square of the hypotenuse. So, no. Okay? In part B, I didn't write this out because I want to explain it. Once you know which length represents the hypotenuse, does it matter which length you substitute for A? Which length do you substitute for B? No, people, no. Doesn't matter what you sub in for A and B as long as they're legs. They're both legs. All right, moving onward. In your notes, there's one other feature here that you need to understand, because to extend this idea, if it's not a right triangle, then what is it? So if it's not a right triangle, there are two options. It's either acute or is it obtuse? So how do we know? Well, of course, there are theorems to tell us that. So there are two cases. Case number 1. If the square of the hypotenuse is bigger or greater than the square of the legs, then what do you think? Then it's obtuse. Wouldn't even need to look at a picture, we would just know. So in this case, the square of the hypotenuse was not bigger than the square of the legs. That means if the square of the hypotenuse was smaller or less than the square of the legs, then you have an acute triangle. A cute little triangle. So go ahead and try the last got it problem. Got it problem number 5 on page 495. Guess I didn't have to tell you the page. Good luck. Okay, I've done my calculations. Now it's just a matter of, is it acute or is it obtuse? Because it's definitely not right. Okay, I got the square of the legs, the sum of the square of the legs to be 113. Got the square of the hypotenuse at 81. So the square of the hypotenuse is actually less than the square of the legs. So what does that mean? It is acute. Okay, we got another cute little triangle. If I can get back to the page, which I can't. Well, yes I can. Alright, so I'll write that on there. This is acute because the square of the hypotenuse was smaller, was less than the square of the sums of the legs. Okay? Alright, people. Onward. Go ahead and practice, practice, practice.